Hey guys, this is Coach Brian with our 12.1 notes. 12.1 is all about three-dimensional shapes, so you're going to start needing to think about three-dimensional shapes and learning how to, look at their sketches, identify the different parts, pieces, and all that. And so, getting started with day one of this unit, we are going to be finding surface area. Surface area is the area of the surface. I know that sounds dumb to say, but 3D shapes have three dimensions. They have a height, they have a width, they have a depth. So they take up space. So far, everything we've been talking about this year has been flat and two-dimensional. And so when we're adding in this third dimension, you need to think about the space that things are taking up. So to start off with, we're going to be looking at prisms and cylinders. All right, prisms have two polygon bases. And a really good idea would be to go ahead and identify these first when you're working a problem. Because if you are not correctly oriented, meaning you think, the height is something that's not, the base is something that's not, the edges are something that they're not, everything you do from that point forward is going to be wrong. So always identify those first. Second, the prisms are named for their base. And lastly, the sides are always going to be rectangles. All right, so that brings us to our first little example. It says, color the bases, mark the height in another color. So remember, the bases are going to be polygons, the sides are going to be rectangles. So what I want to do for all three of these is I want to identify their base. So for this first one, the bases are these two squares. So I'm just going to shade those in real lightly. All right. And the height is, I told my students, another way to think about height, let me actually do this off to the side. Another way to think about height is ask yourself, how far apart are the bases? And so if I have this green base right here and this other green base right here, the height is the distance between them. All right, the height is the distance between them. That is our height. Let's move to the next one. We are going to identify the polygon first. Well, guess what? That's a triangle. So that's base number one. A triangle over here. That's base number two. And then ask yourself, how far apart are the bases? That is this distance. That's our height. Okay? How far apart are they? That's our height. Lastly, for this final example, I'm going to identify my shape, which is a circle. I'm going to shade it in. Those are my bases, and then I'm going to ask myself, how far apart are they? Because that number is my height. And then lastly, we need to name these. So our first one, it has square bases. So it is a square prism. Our next one has triangle bases, so it is a triangular prism. And our last one has circles, but we're not going to call it a circular prism. It's got its own unique name. That is a cylinder. All right, and we have a couple of new formulas. We're still going to be using all the stuff we've been using from the past, all of our other area formulas. But we have a couple new formulas for our surface area. The first is lateral surface area. When you see the word lateral, you should think sides. And lateral surface area is only the sides of the shape. The formula for this is P times H, where P is the perimeter of the base, and H is height, which again, you should think, how far apart are the bases? Distance between bases. That's our height. And that's sides only. So remember, like all of these shapes, they have sides, and we're ignoring the colored in part to start with. Think of it as like you're ignoring the top and the bottom, or the two furthest sides. Whatever those polygon sides are, you're leaving those out for lateral surface area. But for total surface area, you're including it. It's going to be the sides and the bases. This has a really similar formula to the one we just did. It's going to be P times H, because it's still the sides, plus 2B. And in this case, B stands for the area of a base. To find the surface area, add the lateral and the bases. So that's what we just said. Lateral, P times H, plus bases, 2B. When you're working a problem, if it asks you to find the surface area, it's almost always going to mean total surface area. You're going to find that one way more than lateral. Now, you do need to pay attention, because it may specifically say, find the lateral area. All of today's examples say both. So we have 1, 2, 3, 4, 5 examples to work through. Let's go ahead and get started. First one says, draw a rectangular prism with a height of 22 centimeters, length of 8, and a width of 5. So I'm still thinking of height as the distance between my bases, and then I'm thinking of length and width of this rectangle, the end of the shape. So what I'm going to do is I'm going to go ahead and sketch this out. I'm going to create a rectangle first. Probably made that a little too big. Let's shrink that a little bit. And I'm going to put it further down so that I have more room. So this is our 8 by 5 rectangle. And then we have another one of these. Okay, another one of them, because we have two bases that are identical, and they are separated from each other. And when you say how far apart are they, that's actually your height, which is 22 centimeters. So we've got all of our sketch here done. We've got our 8 by 5 rectangle, and they're 22 centimeters apart. So you could think of this almost as like being a box of cereal. First, we want to find the lateral area, which is all the sides. Okay, sides. So we're pretty much finding everything but the top and the bottom of this cereal box. Okay. Think cereal box. All right, so our formula for that is P times H, and P is going to be the perimeter of the base. So what I need to do is I just need to go to the base, which I'm outlining in green, And I need to find the distance all the way around it. So it's got a side of 8, another side of 8, a side of 5, and a side of 5. So when I add 8 plus 8 plus 5 plus 5, I get a perimeter of 26. And I'm going to multiply that by the height, which is how far apart are the bases. And I'm going to get 26 times 22, which is 572. And that is an area, so that is centimeters squared. 572 centimeters squared. Now that is just my sides. That is excluding the ends. So now to find the total surface area, I want to include them. So I'm going to do P times H plus 2 times the area of the base. Now again, pH is our lateral formula, so I already know that part of this equation is going to give me 572. But the 2b is going to come from the area of the base. So I have a rectangular base that is 5 by 8. And so to find the area, I do 8 times 5, and I get 40. So it's going to be 572 plus 2 times 40. Well, 2 times 40 is 80. And 572 plus 80 is 652 centimeters squared. Next, I'm going to jump to example number 2, which is to find the lateral area, P times H, and the surface area, P times H plus 2B, of the right triangular prism. That's a lot of information right there. First key part is that this is a right triangle on the bases. It's a right triangle. Second thing that I've told my students today to help them is like highlight your base like we did for question number 1, or the very introduction of the notes. Highlight your base or color it in. But then I like to draw it as if I'm looking at it straight on. So it's a right triangle. Okay, right triangle. If I was looking at this just straight on, so I see it's got a 90-degree angle. And then this side is my hypotenuse. This side is my short side. And then they give me down here the medium side of 4. And if I didn't know what that was already, I could use the Pythagorean theorem. But they do give me all sides, and this is a 3, 4, 5 triangle. So when I have this 3, 4, 5 triangle, the perimeter is going to be 3 plus 4 plus 5, because those are all my sides, and my height is going to be 7. So when you do 3 plus 4 plus 5, you get 12. When you multiply that by 7, you get 84 square centimeters squared. Now for my next one, I still need pH, which we just said is 84, but I'm adding 2 times the area of the base. So if I look at this base, it's got, pick a different color so it's a little brighter. It's got a height of 3 and a base of 4. Height of 3, base of 4. And the area of a triangle is BH over 2. So 3 times 4 over 2, which is 12 over 2, which is 6. So the area of this triangle is 6. So 84 plus 2 times 6. That's 84 plus 12. And so altogether it equals 96 square centimeters. Moving on to cubes. What is the shape of each face of a cube? each face of a cube, like I'm coloring in right now in yellow, is a square. Each face is a square. So since each face is a square, that means all of their sides are the same. All their sides are the same. And since all their sides are the same, that is what we're going to call an edge value, okay? Because all these edges are the same. Since all the sides of the square are the same, all the edges are the same. So it says, how many faces does the lateral area include? Lateral area is our sides only. And so you're ignoring the top and the bottom bases. So the top is going to be the area I'm shading in now, and the bottom would be where I'm shading, but obviously the underside. So think about it like a dice. If you have 1 through 6 on a dice and you take away the top and the bottom, you're only left with 4 sides. And then how many faces does the total area include? It includes 6. And then don't worry about this up here. All right, so using this knowledge that we just found, example 3 says find the lateral area. That's going to be P times H. And the surface area is going to be P times H plus 2B of a cube with an edge of 9 inches. So the important thing for this is that all the sides are squares and all of their edges are the same. So using that knowledge, we need to try to figure out what the edge value is. All right. To do this, this is probably the hardest part of this problem, is to get this set up correctly. We're trying to figure out E. So we have a cube. Okay, I'll just sketch a little one right here. We have a cube, and our cube, every value that we need on it is 9. So the width, the depth, and the height, they're all 9. So now we just actually use our same formulas. First, excuse me, we need our perimeter. So you have a square base where all the sides are 9. All the sides are 9. 4 times 9 is 36. So my perimeter in both of these problems is 36. My height, since this is a square, is also going to be 9 because all my sides are the same. All my sides are the same. So 36 times 9 is going to be my lateral area. 36 times 9. That gives me 324. So lateral area equals 324 inches squared. My surface area is going to be that same 324, but I'm also adding 2 times the area of the base. Well, again, the base is a square that is 9 by 9. When you have a square, area equals side squared, or side times itself, and 9 squared is 81. So the area of this is 81. So we're going to say plus 2 times 81. 2 times 81 is 162. So we've got 324 plus 162, and it equals 586. 586. Now again, this is an area, so we've got our units. Sorry, I'm trying to double check my work on the calculator and I'm not multitasking very well. Yeah, I made an error. I shouldn't have carried a 1 right there. Sorry. Quick error. 486. Our units are inches, and that is squared. 486 inches squared. So there's our two answers for that. All right, like I was saying, setting this up to like solve for the edge value can be difficult. So we're going to do that in example number 4 together to show you how it works. This one says the lateral area is 25. Find the length of each edge and the surface area. So we need to find what E equals, and we need to find the surface area, which is going to be P times H plus 2B. P times H plus 2B. Excuse me. All right, let's start with what we know. We know that the lateral area is P times H, and that it equals 25. So think about this. This is a square. The perimeter is found when you add up 4 edges or 4 sides. So our perimeter is 4E. Again, though, this is a square, so our height is also going to be E because all the sides are the same. So I've got 4E times E equals 25. And if I work that out, 4E times E, 4E times E is going to give me, I didn't want to do that. 4E times E is going to give me 4E squared equals 25. So first thing I want to do is get rid of this 4. E squared equals 6.25. Next thing I want to do is get rid of this exponent of 2. Powers and roots work against each other. So those cancel. E equals the square root of 6.25, which is 2.5. That is my first answer. It shows me that all of these sides of this square are 2.5. Every one of them is 2.5. Now my last step is to find surface area. So I need to do perimeter times height plus 2 times area of the base. Now here's the thing. pH is my lateral area, and I already know from the instructions that it's 25. So now I need to figure out what the area of one base is. So it's a square that's 2.5 times 2.5. And that we just saw from right here, 2.5 times itself is 6.25. So my area of my base is 6.25. And now I'm just going to add these up. That's 12.5. 25 plus 12.5 equals 37.5 inches squared. There are our two answers. All right, moving on to our last little section. Cylinders. Cylinders are really similar, but their bases are circles. So we're going to need circle or circular formulas. All right. First, let's talk about what a cylinder is. A cylinder has bases that are circles and a side or I guess you could say sides. That is a rectangle. If you're wondering how the side is a rectangle, think if you took a rectangular sheet of paper and you rolled it into a tube, it would create the walls or the sides of a cylinder. So maybe that will help you think about how the one rectangle makes all the sides of the cylinder. All right. Our formulas are actually the exact same, but we're going to replace some things with circle-specific formulas. For instance, the distance around a circle is called the circumference. So we could say, instead of perimeter, it's circumference times height. And maybe you don't know circumference off the top of your head. So it might be even better to write circumference equals 2 pi r times height. So these all say the same thing. All are the same. They're all the same thing. The perimeter of a circle is the circumference, and the circumference is 2 pi r. So I didn't really change anything except which variables I was using. And I can actually do the same thing with the next one. We already said that P times H can be replaced with 2 pi r times H. And then B is the area of the base, which we can replace with the area of a circle, which is pi times radius squared. So again, this is my perimeter, this is my height, this is my base. It's all the same thing. I'm just substituting formulas with variables, substituting variables with formulas. All right, let's actually put some of these to use real quick. Example number 5, it says the net of a cylinder is shown. If you're not sure what a net is, it's like if you took a shape and you unfolded it. Or you deconstructed it. So think about it. If I took this piece of paper and I rolled it into a tube and then I closed this and I closed this, it would give me a full cylinder. So drawing them in this net form is just a way to kind of more easily see its pieces. So we're looking for surface area only. That's going to be this formula right here. It's going to be 2 pi r times height plus 2 times pi radius squared. So I really need 3 things from this picture. I need the radius and the height. So all the way across this circle is 5, which means the radius should be halfway across the circle. Half of 5 is 2.5. So radius equals 2.5. And then our height is our distance between our two bases. So if I folded this shape back up, the two bases would be 8.4 meters away from each other. So I have the two numbers I need, and I just need to plug them in now. 2 times pi times 2.5 times the height is 8.4 plus 2 times pi times radius squared. All right. Now I'm just going to work these out. 2 times 2.5 is 5 times pi is 5 pi times 8.4 is 42 pi. You can see I'm leaving everything in terms of pi. I'm leaving the pi alone. Over here, 2.5 squared is 6.25. 2 times 6.25 is 12.5. Don't forget my pi. And then I need to add these together. 42 plus 12.5 is 54.5 pi meters squared. That's the surface area of this deconstructed cylinder. All right, last you have a writing question that says, what's the difference between lateral and total surface area? So make sure you give a good quality written response so that you can get full points and make your teacher proud.